Lab 10, Predator-Prey Simulation. Introduction. A population consists of all the individuals of a species that live together in one ecosystem. A biotic interaction occurs when an organism interacts with another living thing in its environment. Biotic interactions can be one of three types: competition, predation, or symbiosis. This lab will examine the effect of predation on population growth. Populations grow in a predictable manner. When their growth is graphed, all populations go through a lag phase, where growth rates are slow due to the small number of individuals reproducing. When the number of individuals is large enough, the population growth rate dramatically increases. This phase is known as the exponential growth phase. Depending on the organism, a carrying capacity may be reached or the population may crash to near zero. Predator and prey populations are connected to each other. To survive, predators must depend on populations of prey animals. The number of prey animals affects the number of predators. Likewise, the number of predators affects the number of prey animals. In this activity, you will simulate the predator-prey relationship between two forest animals that play different roles in their woodland habitat. Materials: 300 beans, the mice; graph paper; 2 sheets of paper taped together, the meadow ecosystem; 50 3-inch paper squares, the owls. Procedure: how are populations affected by predator-prey relationships? This lab will simulate 25 generations of owls and mice living in a common habitat. Population studies have revealed that there is 1 owl and 3 mice living in this ecosystem. This information is recorded on Table 1 for the first generation. For this simulation, 2 individuals will be owl managers and 2 individuals will be mouse managers. The owl managers will be responsible for maintaining and recording the owl population. The mouse managers will be responsible for managing and recording the mouse population. Each individual should have a complete table. Number 1. Tape together 2 pieces of paper side by side. This is your ecosystem. Number 2. The simulation begins with the mice managers distributing 3 mice into the ecosystem. Number 3. The owl managers toss an owl square in an effort to capture as many mice as possible. If the owl card lands on any part of the mouse is caught. The owl must capture at least 3 mice to survive. With the mouse population so low, survival of the owl is nearly impossible. Remove any dead mice and owls from the meadow. Place them back into the reserve bags. Number 4. The mouse population reproduces at the end of each round. The mice managers will multiply the number of mice in the mice remaining column by 2 and enter the result in the number of mice column for the next round. Add enough mice from the reserve to the meadow so that it equals this number. The number of owls doubles also. This is the responsibility of the owl managers to track the totals and add owls to the meadow. If no owls survive, then a new one moves into the area. 5. By generation 5, the owl should be able to capture 3 mice when the card is tossed. If successful, the owl survives and produces offspring, 1 for each 3 mice caught. As the population builds, it is important to accurately tally each owl kill. Remember, if an owl kills 6 mice, it produces 2 offspring. It's number 7. If the population of mice ever crashes to 0, then 3 new mice move into the meadow. Number 8. Continue the simulation for 25 generations.